small part about velocity, and then we will move to lesson number 2, acceleration. Okay, so guys, what is velocity? Let us suppose that two birds start from the same place and fly at, for example, 10 km per hour for 5 minutes. So why might they not end up at the same place, guys? What do you think? Yes, because the birds were flying in different directions. So there are times when the direction of motion must be included in the measurement. So sometimes, guys, direction of motion is very important, and we need to consider the direction by which certain object is moving in our calculation. So guys, from here we need to describe a term called vector. What do we mean by a vector? A vector, guys, is a quantity that has both sides and direction. So guys, again, a vector is a quantity that has both sides and direction. So you may remember that yesterday we explained speed, but if we need to use speed as a measurement for something, we don't need to explain which direction this object is moving. Okay, so it's just used to describe what is just used to describe the distance that this object is moving through a certain part, through a certain time. Okay, so why, guys, for velocity actually, whenever we need to talk about velocity, we need to consider the direction. That's why, guys, velocity actually is speed, but is a speed in a specific direction. Okay, so this is the main difference between velocity and speed. In speed, we don't need to consider the direction, while in velocity we need to consider the direction. Okay, so velocity is speed in a specific direction. So objects can have the same speed but different velocities. Why? Because of their direction of travel. So for example, two objects are moving, one to the left, one to the right, but actually both of the objects are moving at the same speed, but because they are moving in different directions, so that's why we say that they have different velocities. So guys, for velocity we have a measurement called average velocity. Average velocity depends on the distance from the starting point to the final point. Okay, so for example, average velocity can be 0 km/h if you travel at a certain speed to one point and then travel back to the starting point. So here we can see that average velocity is calculated in a different way than average speed. So average speed, if you remember, average speed depends on what? Depends on the total distance traveled along a path, while, as we said, average velocity depends on the straight line distance from the starting point to the final point, or the displacement, in another word. So guys, here we have some questions from the lesson review for the first lesson. Let us try to answer some of them. So here, motion is a change in position over time. For question 18, a reference point is a location to which you compare other locations. What do you think, guys? That would be the answer here. Exactly true. A reference point is a location to which you compare other locations. What about question 19? Distance traveled doesn't depend on the path you take, guys. Yes, false. Actually, distance traveled depends on the path you take. Okay, so for 20, guys, to calculate speed, you first need to find the mass of an object. Remember what we said about speed? Speed, guys, is equal to the distance traveled over time. Okay, so there's no need to calculate or to find out the mass of an object, so it will be, the answer here will be false. Okay, so for 21, guys, average speed is a way to describe the speed of an object that may not always be moving at a constant speed. Okay, well done. Then here is true. Average speed is when you want to describe the speed of an object that has a different speeds. Okay, that this object is not moving, as we said, at a constant speed. Okay, sometimes it will speed up, sometimes it will speed down, and so on. Okay, for question 22, guys, in the graph at the right, the object is moving at a constant speed. Guys, what do you think? Yes, true, constant speed. Why? Because as we can see, we have a straight line that is what keep moving up. So guys, this question from 1 to 4 will be homework for you. You need to draw a line to connect these 4 terms to their definitions. This is gonna be easy, inshallah. So for question number 5, guys, what information do you need to describe an object's location? Remember our first slide in the previous lesson, we said that an object's location is described using what? Using a position and a reference point. So we need to know the position of these objects and a reference point. Okay. For question number 8 from the lesson review, guys, what do you need to know to describe the velocity of an object? So to describe a velocity, what do we need, guys? As we said, velocity is a speed but in a specific direction. So if we need to describe speed, we need to know what? We need to know the distance that will be traveled and time. But for velocity, we say we need to consider another thing, which is the direction of this object or the direction of the motion. So the answer here, guys, to describe the velocity of an object, we need to know the direction, as we said. We need to know the time, and we need to know the distance that will be traveled. Okay, so guys, let us start our second lesson, which is acceleration. So how do we measure changing velocity? Guys, actually acceleration is the rate at which velocity changes. So we have two kind of velocity. We have the average velocity and we have what? A changing velocity. Changing velocity actually is called what? Acceleration. So guys, when do an object an object accelerate? An object accelerates if its speed, direction, or both of speed and direction change. So if any object changes speed, like it slow up or it slow down or speed up, then we say that this object is accelerating. Or if a certain object moved from one side to another, so here we have changing in the direction of the motion, then we can say that this object is accelerating. So again, an object accelerates if its speed, direction, or both change. Okay, acceleration depends on how much velocity changes and how much time that change takes. To understand this point, guys, let us have a look at this diagram. What is the change in velocity for each second of time that passes? Guys, as you can see here, a second 1, this object was moving at speed equal to 1 meter per second. Okay, then a second 2, the speed increased actually to 2 meters per second, and then at second 3, again the speed increased to 3 meters per second. So we can see that the speed of this object is what is increasing, and we can see that this object is still moving in the same direction. Okay, and this object is moving, as you can see, to the right. Okay, then at second 4, the speed of this object increased to 4 meters per second, and then at second 5, the speed increased to 5 meters per second. So you can see as the time increased, or as the time passed, the speed is what is increasing. Okay, increased from 1 meter per second to 5 meters per second. Okay, so we can say that this object is accelerating. There is change in what? In the speed, but there is no change in the direction, but still this object is accelerating. This object, as you can see, is speeding up. Okay, so if we want to calculate the average acceleration, guys, average acceleration is equal to final velocity minus starting velocity over what? Over time. So again, average acceleration is equal to final velocity, which is v2, minus the starting velocity, and we represent doing the starting velocity by v1 over what? All over time. The unit here, guys, will be what for velocity? The unit is meter per second, and since we have another unit for another time, then we'll have the second will be what square. Okay, so the unit for acceleration will be meter per second square. So how can accelerating objects change velocity? As we said, acceleration refers to both increase and decrease in speed. A change in direction is also what? Acceleration. So an increase in velocity is called what? Positive acceleration, while a decrease in velocity is called negative acceleration. So actually both of them is acceleration. For increasing in velocity, we call it positive acceleration, but if velocity is decreasing, then the acceleration will be negative acceleration. So guys, we have this question: is the horse showing negative acceleration or positive acceleration? And explain. So guys, what do you think? At 0 seconds, speed of the horse was equal to 13 meters per second, while the velocity of the same horse after 5 seconds was 5.5 meter per second. Okay, so what do you think, guys? Is this horse showing a negative acceleration or positive acceleration? As we said, negative acceleration if the velocity of an object is decreasing, while positive acceleration will be if the velocity of an object is increasing. And here we can see that the velocity decreased, guys, from 13 meter per second to 5.5 meters per second. Then this horse actually is showing negative acceleration. So guys, last thing that we have to know is that we have a kind of acceleration called centripetal acceleration. Guys, centripetal acceleration is acceleration in a circular motion. So guys, if an object traveling in a circular motion, this object is always changing its direction, right? And so it always experiences acceleration, and this type of acceleration is called centripetal acceleration. Okay, so guys, that's all for today. Inshallah, next lesson we will have more questions. We need to practice some of the questions in lesson 1 and lesson 2 together, inshallah. So see you inshallah later.